in this video. So in this first video, I should tell you how you can access the values and how you can, change them if you want to. So in this will, if you want to access them, you would have to use load word to bring them to the CPU. If you want to change them, you have to use store word. So store word is the command that goes to the RAM. So again, in yesterday's video, we made a mistake and we used load word, but we should have used store word to put the stuff in the memory. Okay, so let's say you want to put some value in the first item. Let's forget this loop for now. I'm going to actually remove this. And I'm going to say my array 0 is equal to 10. My array 1 is equal to 20. My array 2 is equal to, 30. My array 3 is equal to, 12. And let me make this one 34. Okay. So that's what I want to do. So for me to be able to do that, I have to send this value 10 to the RAM because I know that this one's going to be in the RAM in the static data. So let's do that. Now we know that store word has a particular syntax. The syntax is register, immediate, and then there is a register here. Now this particular version of store word is not going to work for us because we have a label here. And for us to use the label, we cannot use this version of store word. So there's another version of store word. But before I do that, let me open Keynote. I want to make sure that you kind of understand what's happening here. And I think the best way to do that would be to draw the array again. Okay, so I'm going to copy this, paste it, and I'm going to remove all of that. And I'm going to unmerge. And I'm going to remove the color also for now. Okay, so we have so as you remember from yesterday, we have this space, which is really for the stack and the heap. We haven't talked about the heap. We don't want to use the heap. Then there's the static data, which we called dot data in MIPS. And that's really where the global stuff go. And then there is the code, just kind of a, so that's how we're going to do it. And the stack pointer is going to be pointing to the first byte outside of the stack. So that would be here at the beginning. And then of course it would be moved. So let's get rid of this. Let's move the stack pointer to here. And let's say this is the stack, for example. Let's give it another color. And here we're going to have some static data. And here we're going to have some code. So when we do this, we're going to have to allocate 16 bytes. So we need more for the static data. So we need actually another row. So that would be the static data. And that would be the code. And let me get rid of that stuff here because we're going to probably be using. Let me replace it with what we have here. That's good. So when we convert this code, I need to change this. When we convert this one to MIPS, it becomes dot data and then my array dot space 16 bytes. Now, For this video, pay attention if I make any mistakes, please. Because it's easy to make mistakes, believe it or not. Even though I've done this for many years. Okay. So yeah, so this .data16 is going to allocate those 16 bytes. And then here, I'd like to put 10 here. I would like to put 10 here. There's no 10 here yet, but I would like to put 10 here. And I would do that by writing code that when this code is executed, we're going to put 10 here. So only when the code is executed, 10 is going to go there. So what you need to know is that this label, my array, is going to contain the first address of this space. So here we're going to allocate 16 bytes, which is all of that. And my array is going to contain the address of this byte. Let me make sure I see the chat in case you have any questions. Yeah, so my array, the label is going to contain the address of this byte. So that's how it works. Now, I did say that there's another version of store word. Let me write it here. You can actually do the following: store word register. Instead of having an immediate register, which is really what we have, you can have a label here. You can replace the immediate with a label. That's allowed. So knowing that this is proper syntax, and knowing that my array is going to contain the address of this byte, can you give me an instruction that's going to put the value 10? Essentially this instruction. So an instruction that's going to put the value 10 here. Think about that for a few seconds. Okay, so Anthony is saying this. Okay, I think this is good. So each student gave a line. So the first, what Anthony said is maybe we should put 10 in T0 first. And then Katie proposed this one. We can take the 10, so T0 contains 10. We can take the T0, which has 10, and we can put it, my array, which is here, excuse me, my array is here, plus SP, so that's going to be somewhere here. You see where my mouse is? That's where it's going to be. Is that where we want to put the 10? If you're going to take SP and add to it this address, you're going to end up somewhere here. Because we know how store word works, right? We take this one, we add this to it. So what should we change? This is not correct. What should we change? So we'd like to stay here. So my array is here and we'd like to stay here. So, okay, that's good. So Anthony is saying we add 0 to it. That's good. So that would be 0 like that. So this is correct. So we put 10 in T0 and we take this 10 or T0 and we put it in the RAM at this location, which is my array plus nothing, which is going to be here. How about for 34? Who wants to do 34? All right, so this command is these two lines are going to put 10 here. So the question now is how can I put 34 here? I'd like to put 34 here. How can I put 34 here? Let's see what the proposed solution is. So here's the proposed solution. So we put 34 in a register, say T0. I like that. I like this line. But then what are you doing here? What's V1? What's this V1? So you looked at the registers. Let me open the simulator. Are you talking about the simulator? Let me see. Yeah, well, this is not this V0 and V1. These are registers that we need to use at some point, but clearly you don't want to do this. So what would we like to have here? Can someone tell me? Like, what would we like to have? What value? Let's talk about, forget about registers and numbers. What value? What is the value that you want to have here? 4. That's good. So Anthony's saying 4. That's great. Can I put 4 here? I can't because I have to put a register here. So how about I no create another temper. Okay, that's good. So Kate is saying, how about we put 4 in a register, say maybe T1, and then use T1 here. And this is really what you want to do. So you can say add immediate T1. And you can say 0 here, 0 here. And you can say 4. And then you can put T1 here. And that would actually do it. So now my array contains the address of this byte. We add 4 to it. We end up here. And we can put T0, which is 34. Is that good? Give me a thumbs up or thumbs down. Okay, so this is good. This is great. This is a great suggestion, KD, because we needed to do that because otherwise we wouldn't be able to use the correct syntax. And we need to be able to correct this. We need to use the correct syntax. So, and of course, the one after that is not very difficult right now. You get the idea. I'm going to just copy it, paste it. I'm going to put 20 here, and then I'm going to put 8. And that's it. You just put 20 because that's really the value that you want to assign to here. And you want to say 8 because you're starting here and you want to get to here. So it's really not that difficult, I think. I think this is good. I'm going to do another example, and then maybe we can go to, we can stop the recording and start a new one and talk about looping, replacing this with a loop and see how we can convert that. So I'm going to say, let me do this. And I want you to help me with this one. So I'm going to say here 2 and then int. Actually, here's what I'm going to do. Here I'm going to say 1020. And then I'm going to define a local array. So I'm going to say int okay. Int my local array, 2. And then what I'm going to do is I'm going to say my local array 0 is equal to, let me just give it the name m. M0 equals to my array 1, and then M1 equals to my array 0. So essentially what I'm doing here is I'm swapping in the first element of this local array, I'm putting 20. So really, after we're done, I'm going to write this here. After we're done, M0 should contain 20, and M1 should contain 10. Okay. All right, so who wants to start here? This is a lot of, and I do want this to be interactive, so I'm going to be giving you a few seconds after each, after each question that I have. So who wants to start? All right. So KD is saying we can start with the global section, so we can do dot data. And here, because we have the values, we have to use dot word. That's great. So we can say my array, then colon, then we would say dot word, and we would list the values, in this case 10 comma 20. 10 comma 20. Okay, that's good. Now we're going to have the dot text section. And here I want to write this code. So the first thing that I want to do is allocate space for my local array. Who wants to show me code to allocate space for my local array? All right, so this is great. Anthony, you're suggesting that we move the stack pointer. And let me actually remove those. And let me put here 10, and let me put 20 here. And Anthony, you're proposing that we move the stack pointer by 8 bytes. And this is great. So we can move the stack pointer by 8 bytes. And of course, that would mean, as you've written, add immediate SP, SP, -8. So that's going to essentially allocate this space. Now, before I put this 10 here, I have to bring it from the RAM to the CPU, and then I have to move it from the CPU to the RAM. So who wants to show me the code that's going to retrieve this, actually in this case, this value, the second element, and put it in a register? So that's going to be the first half of the solution. So I'll give you a few seconds to give me the MIPS code that's going to bring this 20 from the RAM and put it in the CPU in a register. Okay, so Anthony gave me an answer that isn't 100% correct, but it's close, so I'm going to write it. So load word, so this is good. We do want to load word. And let's put it in T0, that's no problem. And we can use my array as a label, that's great. And then here, what Anthony proposed is 0. Now, if you do this, that's going to bring this item, the first item, which is the 10. If you look at this code, that's what I wanted you to translate to MIPS. So it's not the first item, it's the second item. So I have to move my address so that it's here. So I'd like the addition of this plus this to end up here, and then I would want to load. So how can I do it? We did that a few minutes ago. I think you're writing the answer. Okay, so Anthony's saying, how about we put 4 in T1? Okay, that's perfect. So how about I say add immediate? That's really what Anthony's proposing. We can use T1, and we can put 4 here, and then we can put T1 here. So you can actually use T0 here. It's allowed. And I'm going to use it just so that we know what's going to happen here. So it's allowed to use T0. There's nothing wrong with using T0. If you use T0, what's going to happen is 4 is going to be in T0. And then we're going to add 4 to my array, and that's going to be here. And when we load those 4 bytes, which is the 20, we're going to overwrite T0, which is okay because you don't need T0. You don't need this T0, which is really the 4, after this command. So if by the end of this command, T0 gets overwritten, it's okay. There's no problem. So we're going to do it this way. Okay, so that's great. So right now I have this value in the CPU, in a register in the CPU. And now I want to put it here. So I want to do a store word. Anybody wants to do that? So I want to store word this at the right place. And the right place is here. Any ideas? All right. So Anthony gave us a solution. Anthony, I think I'm going to use store word. I think that's what you meant. Yeah. Okay. That's good. So we're going to store word T0. And here we're going to do 0. That's the immediate. And we can do SP here. That's perfect. So that's going to put 20 here. So this is good. We did more than half, because now you know how to do it for one element. It'll be easy to do it for the second element. So for this one, do you want to do that? I'll give you a few seconds to do that, and then we can stop the recording and start a new one. So give me the code for both of them at the same time. So we did, all of that, and that's really these 3 lines. Give me the 3 or 2 lines, maybe it'll be 2 lines that will do this line. All right, so we have an answer. Let me copy it, paste it, and look at it together. We can look at it together. So the first one is we put 8 in T0, and then we add 8 to my array. So we end up here. Is that where you want to end up? Okay, so let's ignore the first line. Okay. Well, if you ignore the first line, what do you want to put here? Oh, actually, yeah, I mean, I'm trying to think of what you had in. Yeah, I'll give you a few seconds to make a change. Maybe I should have done that maybe at the beginning. Let make the changes that you need to make. What changes do you need to make here? Resume. Okay, so that's actually correct. So we can just use 0 here because that's what we want. And we can add 0 to my array. We can load the 10 here, and then we can put it at SP plus 4, which is here, and that's going to put 10 here. That's great. Okay, that's great. That's perfect. All right, do you have any questions about this? Give me a thumbs up so that we can move to the new topic if you don't have any questions. Okay, let's stop the recording.